All right, so real quick before we jump in here, while y'all are still kind of tying up loose ends, we are going to test section 6.1 through section 6.2. We're going to test it on Monday, this coming Monday, which will be the 10th, right? No, today's the 11th. Sorry. Back in time. Yeah. So it'll be the what? 16th. Thank you. Monday, 5/16/22. I only know today's the 11th because today's my son's birthday. How about that? How about that? Yeah. Thank you. Thank you. Thank you very much. Yeah. Yeah. And he graduates on Saturday. So, man, he got back from DC. Now he's having a birthday. And he's going to graduate. He's having a big week. He just got back from Dallas on his first assignment for his first paying job. Republican gig with Donald Trump. You know, you had to pay $10,000 to take a picture with Donald Trump. Isn't that something? And he got it for free. Because he works for the NRCC. How about that? What's the NRCC? I don't know. It stands for something. I don't know. It stands for Dad not having to pay for your bills anymore is what that stands for. That's right. Or something, maybe. I don't know if you anyway. That's Monday. Also on Monday, I'm going to post a 33 question multiple choice review for the second semester. And there'll be 3 copies, right? Form A is going to be with the answers that I give you. It's optional. Form B is going to be no answers. And that's just going to be, a quiz grade. And then Form C is going to be your final exam.
So like how we did it before.
Yeah, except what we did at we pretty close to what we did the semester, except the semester we actually counted it as a test grade, Form B. I think, or I gave you four to do. We actually tested over it. We're not going to test over that. I thought we were going to have like 4 tests this 9 weeks and count that as another one, but no, there's just not enough time to do that. So it would behoove you to work it, right, so that you can get 100 on your final exam. Seniors actually start testing next week already. I think on Friday or Thursday. Have you confirmed that? Yeah, there's still no schedule that's out there, but the seniors take them early and they'll be taking them during class. And so the seniors are going to have 20 questions on the final instead of 33, okay, because they have less time. And then underclassmen, we'll run modified schedules so that you have like an hour and a half and you'll take all 33 questions, okay? So once that, we'll know more next week, hopefully, on what that actual schedule will look like. But that's kind of what the rest of the year looks like. So the last grade will be the test grade. And then, of course, your worksheet and your notes for 6.2, those are also going to be due Monday at 9 a.m. Okay, so those 2 in the test. Your retest, if you happen to need to retest for this last test here, your retest is going to be your final exam. Okay, so if you score above a 70 on your final exam, which you should, we'll change that grade to a 70. Okay, sound good? And let's take a look at Corpy's World. Y'all know about Corpy's World? Is it a good resource y'all just learning about here at the end of the year? Yeah. I hope mine do. Right. Let's see. Old tests. Oh, you mean there was a website? Right. What in the? Yeah, that's a nacho reference. Okay, there is no sample test on here that's going to look like the one y'all are going to have. So let me just kind of show that to you here. Or actually, maybe it is. Maybe it is. Hang on. Sorry, I spoke too soon. Yeah, here it is. See, so except this goes all the way through 6.4. There are more identities out there. There's composite identities, double angle identities. We're not going to test over anything except the identities that are in 6.1. But this is kind of what your test is going to look like. You're going to have 2 sections instead of 3. So notice here it says part 1, prove 4 out of 5 identities. These all involve the basic identities. So your part 1 is going to look similar to this, except instead of 4 out of 5, it'll say 7 out of 8 or something like that. But and right now you have the ability to do all of these. These only involve the identities from 6.1. And then your part 2 is going to be solving trig equations. And this is like what we did at the end of 6.1 in those last few examples. And here it doesn't give you an option to do 3 out of 4, but I think you'll do like I'll probably have you do 4 out of 5 or 5 out of 6. And then you will not have part 3. This says to do 3 out of 4 because these involve power reducing identities, composite identities, half angle identities. So we're not going to do that. But notice there is no multiple choice. Okay. So anyway, if you want to start practicing parts 1 and parts 2, you know, is what your test is going to look like on Monday. So you have the ability to do that. And of course, the key is posted as well. The key to worksheet 6.2 is also posted on my website. I don't put that in Canvas anymore, but it's on the website if you want. Just keep in mind though that the way if you look at the key too soon, you haven't really tried it yourself, and there's more than one way to skin these cats. So that's not necessarily the only way to do it. Answers should and will vary. All right, and then that's kind of it, right? After this week, there's only 2 more weeks, and y'all get out on Thursday, the 26th. So not even. I guess 2 weeks from tomorrow. Yikes! It's kind of scary. It's kind of scary because, yeah, I remember like I'm still trying to learn some of y'all's names. Right? Yeah. Okay. All right. Any comments or questions about? Yeah, I'll miss y'all too, by the way. Yeah, yeah.
We'll miss you.
Yeah, thank you. Yeah, right. Hey, remember that you can always just buy the book, Dad Jokes. And let's see. That's right. That's right. Yeah. How much space will Brexit free up in the European Union?
A lot.
1 GB. GB, not gigabyte. Yeah, one, but great. Yeah, yeah. Yeah. Oh, look, here's one you might have heard. I've seen the memes from them, but here's math related. Look, I made a graph of all my past relationships. It has an x-axis, EX, and a y-axis, a WHY. You know what I'm talking about. Hey, no risk though, no reward. No risk, no reward. Okay, let's do example 4. I'm going to copy this just because I want to work it more than one way. So let's actually put this over here. I'll work it over here first. So step 1, draw a line down the middle. Boom. Did you know that Tom Brady has already signed a contract for when he's retiring to be Fox's top color commentator? And he will have made, it's a 10-year contract, but he will have made more money announcing football than he's ever made playing football.
Really?
Right? Yeah, the contract is worth more than he's ever made in salary as a player. Isn't that weird? Yeah, that's weird. Right. Crazy. Okay. Let's see. I'm gonna hold off on Maddie's version first because that was a good one. Would anyone like to volunteer how you proceeded, how you started? Left side or right side? Which one looks more complicated? Yeah, I would say the same thing, right? 6 of one, a half dozen of the other. They both in terms of sine and cosine, they both have quotients, so it's arguable. Would anyone like to then say what you did on which side to start off with, other than Maddie? Because I like what she did. It's kind of an advanced technique. Did anyone start on the left side and put everything in terms of sine and cosine? Okay, good, because it already is, right? Yeah. One thing that we could do on the right side that we can't do on the left side is split up. So let's go ahead and write this. This is a strategy, right? We're just listing strategies. We can split up numerators, which is kind of like what a baby does if it accidentally swallows a numerator, except it spits up numerators, right? Okay. That was not even worth saying out loud, but that it entered my head. See how my brain works? Yeah, I'll miss y'all too. I should write the book Dad Jokes, the ones that didn't make it into print, right? Just the ones that are all so bad they don't even make it. Splitting up, right? Splitting up. No risk, no reward. 1 over cosine plus sine over cosine. And notice the variable is t. So we can't split up denominators like that, right? We can't say that's cosine over 1 minus cosine over sine. But you can split up terms in the numerator by putting each term or any combination of the terms over the entire denominator. So is this the right way to go? I don't know. But it does allow us to do something, right? 1 over cosine now is secant. And sine over cosine is tangent. Now, remember, if you start on the right-hand side, your left-hand side becomes your target. And it would appear that we're actually moving further away from our target, yes? Because now it's in terms of secant tangent, which, you know, our ultimate get unstuck strategy is to put it in terms of the other one. So, wow. So it gives me something to do, but where would I go from here? Well, if you're ever stuck, you can put it in terms of sine and cosine, which would be this, right? And then, hey, to add 2 fractions, you need a common denominator, but it's already a common, so it equals that, right? So we're right back where we started, right? 2 steps forward, 2 steps back. Any ideas? Anyone go this route? No. Okay. Well, what am I going to do? I'm not going to say that I'm wrong, but I'm just going to put this off to the side. Okay. If I ever need to come back to this, I don't want to lose all my work. Okay, but let's just bury that in the cat litter box. All right. So what else can I do? Hey, I'll show you what else we could do. We can do what Maddie kind of thought of, right? We can always multiply by a clever form of 1. Now, she decided to multiply by 1 plus sine over 1 plus sine, which is not wrong. But once I saw that and I kind of said, hey, did you ever think about, did it work better for you? No, having the minus there? Yeah? Okay, good. So one thing we could do is this, watch. If you ever have 1 plus or minus a trig function, notice it's not squared, is it? But if that were 1 plus sine squared or 1 minus sine squared, we could use the Pythagorean identities, right? So what can we do to introduce a squared there? Well, you can multiply by 1 minus sine of t over 1 minus sine of t. How would 1 minus sine of t and 1 plus sine of t be related? With respect to each other? Conjugates, yeah. So another good thing to do is to multiply by the conjugate over the conjugate. It's another strategy. The conjugate over the conjugate is a really great thing to do whenever you have 1 plus or minus a trig function or a trig function plus or minus 1, and they're not already squared, okay? Whenever you expand 2 conjugates, their product is always a what? The product of 2 conjugates is a difference of squares, okay? Now look what happens. If you were to multiply out the numerator, you're going to get 1 minus sine squared, right? Not only is 1 minus sine squared a difference of 2 perfect squares, but it's also a Pythagorean identity. So leave the denominator alone for a while. What is 1 minus sine squared? Cosine squared of t. Good. So multiplying by the conjugate over the conjugate sets up a difference of squares, which then can set up a Pythagorean identity substitution. Okay. So there you go. Not only is 1 minus sine squared equal to cosine squared, but 1 minus sine squared is also a difference of squares. So if you were staring at 1 minus sine squared, like to start with, maybe instead of calling it cosine squared, maybe you factor it as the product of two conjugates. There's quite a bit of flexibility there in your method, but as a method, as to what we want to start with, man, it's very valuable because it sets up a difference of squares, which leads to a Pythagorean substitution. And now look at the left-hand side. Do I not want a cosine of t factor in the numerator? I do, right? Do I have one? I do. I actually have a surplus, right? I have two of them. I only needed one. But that's kind of a hint that you're heading in the right direction, okay? So be looking for the opportunity to multiply by the conjugate over the conjugate. Now, having said that, is there another indicator that maybe is a way to start? Well, the answer is yes. You remember yesterday I said you can create what you need, right? We needed a tangent in the top, so I multiplied, or we needed a tangent in the bottom, so I multiplied by tangent over tangent. Well, look at this. If I say that I want a 1 minus sign in the denominator, and I currently don't have a 1 minus sign in the denominator, let's go ahead and give ourselves a 1 minus sign factor in the denominator. Now, to do that legally, if I multiply by it in the denominator, which is what I want, I have to do what? Also multiply by it in the numerator. So you can also kind of same strategy here, two different indicators for the same thing, is create what you need. One more time, create what you need. Just do so legally, okay? Multiply by a clever form of 1. So that really kills two birds with one stone. Okay, so now that we expand out the numerator, do you want to distribute the denominator? Do you want to distribute the cosine all the way through? No, no way, no how. Because if you look at the left-hand side, I want 1 minus sine of t visible down there, don't I? Oh, and by the way, if I leave it factored, remember that extra factor of cosine that we picked up in the top that I don't want? Well, by golly, by leaving it factored in the bottom, now I'm able to divide out that unwanted factor of cosine. So be careful when you divide out things like this. If you're going to divide out, I need to be able to see what's underneath there. So if you divide out the squared and divide that out, that's kind of how you would do it. I almost prefer that you don't even show that, okay? Just know that one of them divides out and you're left with a single cosine in the top. And now in the bottom, we don't need the parentheses anymore because that's the only thing that's there. There you go. Does the left side look like the right side now? It sure does. So we'll sign off with an easy. Two other strategies there. Look for conjugate over conjugate opportunities. That's when you have 1 plus or minus a trig function. It's not squared over a trig function plus or minus 1. And or create what you need by multiplying by a clever form of 1. Now, splitting it up in the very first try that we did, that wasn't illegal. It wasn't wrong, but it didn't really quite take us where we wanted to go. Now, having said that, would there be any reason why then we couldn't start on the left-hand side? After all, Brady said that they're equally as difficult looking. And the answer is, yeah, we could start over there. What would be a good first step if we started on the left-hand side? Yeah, let me do this as a separate line over here. Or, very good. So I would multiply by 1 minus sine of t over 1 minus sine of t. Is that what you said? Oh, very good, very good. So if I did it like this, would that be incorrect? No, it's still equal to 1. But instead of the middle terms canceling at the bottom, they're going to double. So conjugate over conjugate, right? Now in the bottom, that gives you 1 minus sine squared of t, which on the next line gives you cosine squared of t. So it's okay to kind of skip ahead of 2 lines if you're just focusing on the denominator, but At some point, you need to go back in and fill in the numerator so that every line is equivalent to the one above and below. Do you want to distribute the cosine in the numerator? No, because I want to leave the 1 plus sine of t factored. So I want to leave it visible. So 1 plus sine of t times cosine of t, or cost, if you will, right? And then that's still going to be 1 plus sine of t over cosine squared times cosine. And then one of those cosines divides out, leaving just the 1 plus sine of t in the top and a cosine of t in the bottom. And is that the same as the right-hand side now? Yep. Here's another way to spell fun easy. It's kind of like the street version, right? Fun easy. Or if you just want to abbreviate fun easy, like using an acronym, it's just F, right? Because fun easy is one word. That's probably not the best thing to abbreviate, because then you don't know if there's if it stands for another F word, right? And we know there's at least one other F word in the whole world, right? What? Fiduciary? Is that what you said? Oh, that's a good one. That makes, I guess there's 3 then. Okay. Let's try this. Let's go over here to the third side. And let's see if we can work our way out of the wet paper sack we found ourselves in. Trying it the first way. 1 over cosine of t plus sine of t over cosine of t. That gave us secant of t plus tangent of t. You want to see if we can make this work for us? Well, let's see. I'm trying to show that it's equal to the right-hand side. So let's see. If I do that, is that good? Does that constitute the proof? No, that doesn't quite work, right? That doesn't work. That's like watching episode 1 of Games of Thrones and then watching the season finale of Games of Thrones, right? It's like, I think there's some plot missing in between, or whatever your favorite, Downton Abbey. There's another one.
A step back from the C here, of T plus here's the T. And times the previous step.
Yeah,
by
yeah.
Cosine over cosine. Like cosine of T over
On the first one or the second one?
on the step where you divide it out.
So like from this line here, go ahead and multiply by cosine over cosine.
Yeah.
Which term, the first or the second term? Well, if I do it on the first term, then it's going to hamstring me because now I can't combine them because I need like terms. Let's see if let's see if we can just pick up from here. Hey, can I just square it like that? Is that a legal move? Can you just square an expression without changing its value? 0 squared is still 0, right? 1 squared is still 1, but no. Now, if this were a conditional equation, we could square both sides, yeah? But we can't treat it as such just yet. We're trying to prove it. So some people try to do that. They just square something, and you can't do that. That changes the value. So what could we do? What could we do? Hey, I got an idea. Let's put it over 1. Oh boy, that opens the floodgates now, doesn't it? Can we multiply by the conjugate over the conjugate? Would that work? Yeah, it doesn't have to be 1 plus or minus a number or a function plus or minus 1. As long as there's 2 terms, you can multiply by the conjugate over the conjugate. Let's see what that gives us. In the top, I'm going to get secant squared of t minus tangent squared of t. The middle terms cancel out. And in the bottom, do you want to distribute the 1 or leave it factored? Well, it's just 1, right? So let's just call it secant t minus tangent t. This would be like Sunday afternoon, deliberately going out for a nice little peaceful drive just to enjoy the scenery. Now, remember on your Pythagorean identities, isn't there a way to relate secant squared to tangent squared? Yeah, in fact, secant squared is 1 plus tangent squared. Or you could say secant squared minus tangent squared is the same as what? It is 1. It is 1. Okay, so how's that doing? Well, I'm still heck bent on let's see. Hey, if you're ever stuck, you can put it in terms of sine and cosine, right? Well, I think I'm stuck. So let's call that 1 over cosine of t minus sine of t over cosine of t. And now does state change flip work? Not the way I have it written, because that is 2 terms. But Lickham over Lickham works. I have one little denominator of cosine. So let's multiply by cosine of t in the upstairs apartment and cosine of t in the downstairs apartment. And now if I multiply straight across, I get cosine of t over. And if I distribute in the bottom, I get 1 minus sine of t. Did that do the trick? Yeah, that did the trick. Yeah, did the trick. DTT. So really, it's kind of the same mechanism working behind the scenes. We multiply by the conjugate over the conjugate, which is kind of the magical step that makes this happen. Okay. We just kind of did it after we converted, and then we converted back. So which one of these 3 is correct? All 3 of them. But which one of the 3 is wrong? None of them. Right. On the test, if you get that 3rd version, I'm like, well, good for you. You persisted, right? If it's a test and everybody in the class gets that as the solution, now I'm suspicious, right? I was like, one person did it and then everyone copied, right? Or if you turn in your worksheet and I have an obscure method or path on one of the answers and everyone turns it in with the same obscure path, I'm like, you didn't even try, did you? You just went right to the key. You just went right to the key. Answers will and should vary. Okay. Anyway, any other questions on this one? Or does anyone see like another route? Like, ooh, ooh, ooh. No, let's keep going. All right, so gleaning the the wisdom. Multiply by the conjugate over the conjugate, which sets up a difference in squares, which sets up the Pythagorean substitution. And then once you do that, expand out only the conjugates, leaving the other side completely factored, right? Ready to divide things out. Okay, here we go. Give you a minute or 2 to do this one. Because at this point, it's just, they're really the same idea. You gotta be able to start off on your own, if not finish on your own. So I'll give you a minute or 2 to see how far you get on this one. I'll take attendance. Okay, so both sides look equally complicated. In fact, actually, if I were to say, I think the left side probably looks more complicated, although the left side has a fraction. The right side has a Trig's function that's squared, and it has all secants and cosecants, whereas the left side is nothing squared, and it has at least a cosine. Brady, what side did you start on? The left. And what did you do right away? Yeah, very good. So what I would tell you to do here is try that, right? There's now, since we're increasing our awareness, I see that there's a 1 plus. Yeah, thank you. I see there's a 1 plus cosine. So might as well try. It worked previously, multiplied by 1 minus over 1 minus. Now, if you look at the right-hand side, there's not a 1 minus cosine of theta anywhere in our final answer. But that doesn't mean that it's not at least a place where you could start. So if we, right, yeah, it's similar. If I expand the bottom, I get 1 minus cosine squared. And then if you want to go ahead and jump right to the next line, that would be sine squared. So sometimes just thinking out like in the top or bottom. Now, if you look on the right-hand side, there's a factor of cosecant squared, right? Well, isn't cosecant squared 1 over sine squared? Yeah, so it looks like I'm heading on the right path. Now, in the top, remember I said normally you don't want to expand. You don't want to expand. Should we distribute? Yeah, I don't think anything's going to divide out. So now if you want to distribute, you can. You get secant of theta minus cosine of theta times secant of theta. And now on the top, of course, how are secant and cosine related? They're reciprocals. So what's anything times its reciprocal? 1. Okay. And now you can go straight to your final answer. The cosecant squared is in the front, so you could put cosecant squared of theta times secant theta minus 1. Now you could go straight from there to there. Here's what's kind of nice. If you know from experience that the intermediate step that you otherwise would show, sine squared is 1 over cosecant squared of theta, and then do state change flip, you can eliminate that step because here's what's cool. A factor, something that's being multiplied of one trig function in the numerator is equivalent to the reciprocal of that factor in the denominator and vice versa. So in other words, a sine squared factor in the denominator is equivalent to a cosecant squared factor in the numerator and vice versa. A cosecant squared factor in the numerator is equivalent to a sine squared factor in the denominator. So you don't even really need to show that extra step where it's actually 2 extra lines of calling it 1 over cosecant squared and then state change flip. Okay. Now that only works with factors. It doesn't work with terms. So that's probably the simplest, fastest way to get the answer. Okay. On that side. Did anyone start on the right-hand side? Well, here's what it would look like if you started on the right-hand side. Or can we do it without multiplying by the conjugate? I don't know. If you started on this side, you could multiply by secant of theta plus 1 over secant of theta plus 1, right? That would be an opportunity, but I'm not going to do it that way because it would kind of work out the same way. Here's what you could do. You could say, hey, notice that the right side is in terms of cosine and the right side is not. So I might start off by doing a different strategy. Let's put everything in terms of sine and cosine. So this would be secant, which is 1 over cosine, and then minus 1. Oh, by the way, notationally, secant of theta is not equal to 1 over cosine of theta. I still see some people doing that with the theta off to the side. No. Secant of theta is 1 over cosine of theta. Okay. And now you're like, okay, that looks good. That looks good. But where to go from here? Well, maybe I'll get a common denominator. So that's 1 over sine squared of theta. And then this is going to be 1 minus cosine of theta minus cosine of theta over cosine of theta. So now that's going to be 1 over sine squared of theta times 1 minus cosine of theta over cosine of theta. And you keep matching it to the other side. And you're like, wow, am I getting closer? I don't know. Now, at some point, here's what you would maybe tell yourself. You don't have to multiply by conjugate over the conjugate. Okay. Here's what else you could do. You could say, oh, sine squared is 1 minus cosine squared. Okay. And 1 minus cosine squared is a difference of squares. So it factors into the product of 2 conjugates. 1 minus cosine of theta, 1 plus cosine of theta. So you don't always necessarily need to multiply by the conjugate over conjugate to set up a difference of squares, to set up a Pythagorean substitution. You can actually use a Pythagorean substitution so that you can factor a difference of squares. And now the 1 minus cosine of theta in the top, once you put parentheses around it, divides out with that. And you're left with a cosine in the bottom, which remember is the same as the secant in the top. all over what's left in the bottom, 1 plus cosine of theta. So there you go. There's one that did not require multiplying by the conjugate over the conjugate. It's using what's already there. Both methods are correct. The one on the left, of course, with fewer movable parts, fewer lines, is probably the better of the two, just because it takes up less space, less opportunity for errors. And remember, mathematicians like to be efficient. So the last little thing here, do any obvious math such as distributing, combining like terms, etc. Okay, so tomorrow we'll start with example 6. We'll try to pick up the pace a little bit more tomorrow. I won't necessarily work every single problem 2 or 3 different ways. But right now, again, you're still kind of developing strategies and techniques. After that, it just becomes practice, 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 practice. Okay? Yeah. And we're ending with the Kodiak grizzly bear. Look at that big boy. He's waiting for us at the end. Yeah. Okay, enjoy the rest of your day.